Hey guys, so this is where I'm going to explain how you're going to do all of the calculations needed for your burning down the house project. So what I have pulled up right now is the burning down the house mock calculation. This file is on Canvas. I recommend uploading this document or just having a blank notability slide or a sheet of paper just to write down what I'm writing down, because this is going to be really helpful. So I'm going to start actually here on number 8. So you're going to be using the ideal gas law, right? So you're going to use PIVNERT, PV equals nRT, to solve for this, okay? So the variable that you are going to be solving for that you need to figure out is going to be N. And that's going to be the moles of carbon dioxide. Because if you remember, the whole basis of this project is you're going to have your house. You're going to have your reaction vessel where you mix together the baking soda and vinegar, where you're making the carbon dioxide. Then that carbon dioxide is going to go through the tubing into your house. So you want to figure out how many moles of CO2 you have to make in order to completely extinguish your candles. Because if you fill up everything with CO2, then the candles for sure should be suffocated. So you're going to need then P, V, R, and T to figure this out. So both T and P, you are going to get these numbers from the outline. So there's another document on Canvas, the burning down the house outline, and that's where you're going to get those numbers from. So you have to read the outline in order to get those numbers. For R, that's something that you pick, right? Because you base your R based on what unit of pressure is used. So based on the room pressure and how I measured the room pressure in what unit, you will then pick an R based off of that. So then the big thing you are missing is V, and V is going to be the volume of your house plus the tubing plus the reaction vessel. And then these are things you have to calculate. So you need to determine the volume of your house, you need to determine the volume of your tubing, and you need to determine the volume of your reaction vessel. And then you're going to add all of those up, and then that is going to be V in your equation. P you get from the outline, R you pick based off of the pressure, T you get from the outline, and then after you do that you can solve for N, you can solve for moles of CO2. So I'm going to pause for a second before moving forward now and go backwards and figure out exactly how you will get V, how you will get the volume of your house, your tubing, and your reaction vessel. So what I have here is an example of how you can figure out the volume for your house, your tubing, and your reaction vessel. I'm going to start with the reaction vessel first because that's probably the easiest. Let's say you use a 2-liter bottle of pop. Now, how could we figure out the volume of a 2-liter bottle of pop? My husband's laughing at me. Spoiler, it's 2 liters. Okay, so then yay, you're done. Boom. So if it's a 2-liter bottle of pop, just say it's 2.00 liters. Yay, you're done. Let's say you use a gallon of milk, okay? Well, on a gallon of milk, on the label, it says how many liters it is. Let's say you use like a 1-liter bottle of pop. Then it's 1 liter. So just look at the label for your reaction vessel, and that's going to make your life a lot easier. Done. Moving on. Okay. So your tubing then, if it's a straw or a tube or a paper towel roll, whatever you're using, technically that's just a cylinder. Now, how do we know the volume of a cylinder? Well, this is just a flashback to math class, because chemistry is basically just math, but not. So if you remember, the volume of a cylinder is equal to pi r squared All these are being multiplied times the height. So if I'm using straws, you would measure the height of your straw, and then you would measure the circumference of your straw, right, and then cut that in half. Half of the circumference is the radius. You square that, and then you just multiply that by pi. Let's say you use 5 straws. Well, then measure the volume of 1 straw, and then multiply that by 5. So that is going to be the volume of your straws. But one thing to keep in mind of, what you're probably going to measure the radius in is going to be centimeters. And that's going to be squared then, right? Because you'll take the radius squared times the height, which you'll then measure in centimeters. So your final volume is going to be centimeters cubed. Now, if you remember with the ideal gas law, can you plug in centimeters cubed? No, you have to use liters. But if you remember from a few units ago, centimeters cubed is equal to a milliliter. So 1 centimeter cubed is the same as 1 milliliter. And then 1,000 milliliters is equal to a liter. So you can just take it and convert it to liters, and then you can add that all up. Okay. So then, once you have the volume of your house plus the volume of your reaction vessel plus the volume of your tubing, all of those added together is the total volume of your structure. So your house final volume needs to be in liters, your reaction vessel is in liters, your tubing is in liters. You add them up, and now that is the total volume of your structure. This total volume of your structure is going to be the volume that you plug into your PV equals nRT. So all of those values added up is going to be the final volume that you plug into that. Then you now have P, V, R, and T, so now you can solve for moles of CO2. So now, once you have moles of CO2, this is where you're going to start doing the stoichiometry piece of this project. So for the stoichiometry piece, what you're going to need is the balanced chemical equation for the reaction between vinegar and baking soda. So make sure that you write this down. So the baking soda is actually sodium bicarbonate. And even though baking soda is a solid at room temperature, once you mix it with the vinegar, it's going to become aqueous. So it needs to be aqueous for this to work, okay? The vinegar is actually acetic acid, which is HC2H3O2, and that is aqueous. So that's acetate, the polyatomic ion with hydrogen. You know it's an acid because it's got the H in front. And when these mix, you get carbon dioxide, which is what we actually care about, okay? You also make water. It's technically an acid-base reaction, so there's your water. And then you get another side product of sodium acetate. So this is your balanced chemical equation. All the charges have been checked for you. It's balanced, it's all good to go. So make sure, you might want to pause the video right now and just make sure you've got this written down somewhere. So once you have your moles of CO2 that you solved from the PV equals nRT, you're going to use the moles of CO2 to do 2 stoichiometry problems, okay? So the first thing you're going to do is you're going to convert to grams of baking soda. And remember from up above, the baking soda is the sodium bicarbonate, okay? So what you're going to do is you're going to take moles of CO2, and this is going to be whatever number you solve, okay? And your number is probably going to be different from every other group's number because you're all going to have different volumes of house that you're going to use. So whatever number you get for moles of CO2, which is going to be your answer from Pivnert, you can do stoichiometry to get to a final answer of grams of sodium bicarbonate. I'm not going to show you how to do that stoichiometry. That should be something that you remember from previous units, and if you need a reminder, you can go back and look at your notes for that, okay? Then you're going to do the exact same thing. Take the same number for moles of CO2, whatever it may be. And then you're also going to do stoichiometry to get to grams of the vinegar, which is the HC2H3O2. So once you do this, you'll have grams of baking soda and grams of vinegar for your final answers. Now, your grams of baking soda, good to go. So come test day, you can just go to the scale, measure out that many grams of baking soda, boom, you're done. The vinegar, we're going to have to take a couple extra steps with. So once you have grams of vinegar, that's kind of a problem. So vinegar, as you know, is a solution, right? It's an acid. So it doesn't really make sense to measure the mass of it when it's already like in liquid solution form. So instead of measuring the mass of it in grams, we're actually want to measuring the volume of it in milliliters. So in order to do that, you need to know the density of acetic acid vinegar, which is 1.05 grams per milliliter. With this number, you can convert grams of vinegar to milliliters of vinegar. So to do this, you'll take whatever answer you have for grams of vinegar, which is just going to be your answer from here, okay? You can plug 1.05 grams on the bottom, 1 milliliter on the top, and boom, now you've got milliliters. So now this makes a lot more sense, okay, to have milliliters of vinegar. So you'll have your answer, which will be however many milliliters of vinegar, okay? But there's just one more problem. You might remember we mentioned this last time. Vinegar is not pure acetic acid. Basically meaning when you buy vinegar at the store, it's not pure acetic acid. It's actually only 5% acid. So here's the problem. Theoretically, let's just pretend that this number that you get here, let's say it's like 20 milliliters, okay? So you walk over to the vinegar and you pour 20 milliliters of it, okay? Only 5% of that 20 milliliters is actually acetic acid. So you actually don't have as much acetic acid as you need from your stoichiometry. So you're 95% short. So whatever answer you get from here, because it's only 5% acetic acid, you need to take this number and multiply it by 20. So if you got 20 milliliters times by 20, now 400 milliliters. Then if you multiply it by 20, then within that 400 milliliters, 20 of that 400 is actually the acetic acid you're looking for. And that way you actually have enough acetic acid to do the reaction. So this is the number you'll actually measure and pour with your grams of vinegar from the previous one. So this is how you're going to do your project. If questions come up, please let me know. You can use this video. You can use your notes. Obviously, if you're working with a partner, use your partner, help each other out. This is going to be the calculations portion of your Burning Down the House project.